Question number 2 will test you chapter 3. Okay, we have a figure here, figure 4. So in this case, we have a parcel of mass 2 kilogram is placed on a rough inclined plane. So this is our inclined plane and the surface is rough. Bear in your mind, if the surface is rough, it tells us that the surface is having friction. Okay, it is released from rest and after that it accelerates at constant rate of 4 meter per second squared. So this is basically our acceleration. Okay, we have mass and the question is to determine the coefficient of kinetic friction for the parcels. Mu, we want to find mu. Then to solve this problem, first we have to be able to imagine that the case here is the parcel moving down the plane. Okay, it is moving down the plane. The first thing to do is we draw the direction of forces or what type of forces acted on the parcel. So we have, in this case, we have weight, normal, always perpendicular to the surface, and then we have friction. Then the friction is in opposite direction to the direction of motion. So if we draw the free body diagram, it's going to be your friction is here, your weight is here, then your normal is here. Okay, then you can see here that if we assume this is our y-axis and this is our x-axis, so the angle 30 degree here similar to this position. Okay, then we can see that our w is not lying exactly on x and y axis. Then we need to resolve. Then when we resolve, we'll have here as ws and here is wy. Okay, we resolve. So it is actually the parcel moving because of this component ws. Okay, it is moving down the plane because of the component of ws. Now we want to find the coefficient of kinetic friction, and we can have this from the equation of friction, that is F is equal to mu n, meaning that we can have an idea that we are going to solve this question using x-axis because our friction is in x-axis. So how do we do this is we start with writing equation in x-axis. It's summation of fx is equal to me. Then in x-axis we have ws minus friction because the motion is in this direction. So ws positive minus friction equal to me. Then we expand the equation. Basically ws is equal to w or mg sine theta minus friction is mu n equal to ma. Okay, then we can substitute 9.81 sine 30 minus mu, and is not known so far. Mass is 2 kilogram, acceleration is 4. Then since our equation here, we have two unknown quantity, meaning that we're going to find n first from the y-axis. We now solve y-axis, so summation of fy is equal to 0. There is no motion in y-axis. Then we have in y-axis we have n and also wy. N minus wy is equal to 0. N is equal to wy is mg cos theta. Then we substitute the values, 9.81 cos 30. Then we'll have our normal as 19.8 16.99 Newton. Now we substitute our value of normal in the first equation, okay, in this equation. Then we'll have, and finally you're supposed to have your mu as 0.107.